Hello, everyone. I apologize for my voice. As you all know, I'm not feeling too well. But I did say I did want to do a video of a problem, and so I decided to do problem 65, which was written down on the whiteboard as one of the ones that students wanted to see done on video. So this is chapter 2, problem 65. I'll read it for you really quickly. It says, a student standing on the ground throws a ball straight up. The ball leaves the student's hands with a speed of 15 meters per second when the hand is 2 meters above the ground. How long is the ball in the air before it hits the ground? So I did this problem because it's similar to your the air ball activity that you guys did, where you threw a ball up in the air. It was at some height, and then it hit the ground, and you measured the time. In this case, though, we actually have the initial velocity. So there would be a final velocity right here just before it hits the ground. Let's see, there'd be a displacement if I choose this to be my initial point and this to be my final point. So the total time it's in the air would be my total time. But the initial point, the final point, that means this would be my displacement right there. So I've labeled, I drew a diagram beforehand just to save some time, and then I've now just labeled my diagram. I could even say that my acceleration is pointing down. I could make all these vectors as well. So there we go. I got displacement. I've got the initial velocity. I've got my final velocity. And I've got my acceleration right here. So there's all that, all diagrammed for me so I can get a sense of direction and just a sense of what the problem is doing. If the problem was more complicated, it could have several steps to it, but this one's just kind of going to be a one-step problem, a one-object problem, and you're going to be done. So now that I've diagrammed and labeled everything, I'm going to do my VOVAT. And I'm going to write down all the things that I know. They give me the initial velocity, which is 15 meters per second. I know my displacement, which is right here. Many of you might think the displacement would be 2 meters per second, but that's actually not the case because the displacement, as you guys can see, is pointing downward. And downward, we tend to say, is the negative direction. So I'm going to say I have a negative displacement. And other than that, the other thing I got pointing downward that I know for sure is the acceleration, which is negative 9.8 meters per second squared for an object in free fall. But I'm going to round and just say that's going to be negative 10 meters per second squared. Again, because the AP exam allows you to round, and it just makes the math a lot easier. So next up, I think about so I got three things in my VOVAT right now. So I'll be able to solve for the thing that they're asking for, and the thing that they're asking for is time. So I'm trying to think of what do I need that has displacement, acceleration, and initial velocity, and time. That leaves time as the only unknown. And if you think about it, so I'll give you a moment to think about it. Pause this video if you want to think about what equation to use. And the equation to use, the easiest one to use, is this one. D equals V naught T plus 1/2 AT squared. Typically, I'd say solve variably, but hopefully you can recognize I got one variable there and another variable that's t squared. So when I go to plug in, it's probably going to end up being a quadratic. So I'm going to plug in right now. My displacement is -2. Just simplifying, I'm going to forego the units. My initial velocity is positive 15 multiplied by the time, which is what I'm trying to find, plus 1/2. The acceleration is -10. And the time, again, I don't know what it is, but it's t squared. And hopefully you can see here what I have is a quadratic. I got something that has no variable in front of it. I got something that has a variable to the power of 1 and something to the variable to the power of 2. And hopefully you recognize that I'm going to add 2 to both sides. That'll give me 0 equals 2 plus 15t plus 1/2 times negative 10t squared. 1/2 times negative 10, though, is just 5. So it's going to be 0 equals 2 plus 15t minus 5t squared. All right. And hopefully you can see that this is a quadratic, and to solve a quadratic, if you've forgotten, that would mean that t would equal negative b plus or minus the square root of b squared minus 2ac all over 2a, where this term here would be your a term, this term here would be your b term, and this term here would be your c term. So give me a moment. I made the calculation already. It's in the other room though, so I'm going to run really quickly to the other room and find out what it is to give you the answer. All right, so I've calculated out the answer, and what I have is so what I end up doing when you plug all this stuff in is you get that the time is equal to negative 0.128 seconds or 3.13 seconds. So hopefully you can see that the negative time is probably not going to be your answer. You know, got negative time. There's a reason for this, and if you ever want to talk about it, we'll talk about it later of why you have a negative value for time. But we're going to go with the 3.13 as our answer. So that means that the time it takes would be 3.13 seconds in order for the ball to go from our initial point to our final point. It takes 3.13 seconds. So I hope you found that helpful, and I'll do another one soon before the exam. Thank you.